In this video, we're going to add and subtract polynomials and multiply polynomials. So first, what's a polynomial? A polynomial is a collection of numbers and the variables may have exponents, all added or subtracted together. So what you see here, this is a polynomial with 1, 2, 3, 4 terms. This is a polynomial with 1, 2, 3 terms. There's the numbers. There's numbers with variables, and there's numbers with variables with exponents. A polynomial is in standard form if the biggest exponent is first, and then the exponents decrease until the number is on the end. Okay, so first, adding polynomials. Adding polynomials is as simple as adding like terms. I would suggest rewriting the second polynomial where each term is underneath its like term in the first equation. So we're going to be adding a negative 4x squared. So I'm going to write negative 4x squared underneath 6x squared. We're going to add a negative 10x. So I'm going to write minus 10x. And we're going to add 9, so I'm going to write add 9. Then they're all vertically arranged, so I can just add like terms in columns. So we would still have 3x to the third, since it has nothing to add with it. 6 plus negative 4 would be 2x squared. Negative 8x minus 10x will be negative 18x, and 7 plus 9 would be 16. And we've added our polynomial together. Next, subtracting. Please remember that subtracting is the same as adding the opposite. So before we get started, I'm going to go through the second polynomial, and I'm going to change it to adding the opposite. So instead of negative 16x to the third, it'll be positive. Instead of negative 10x squared, it'll be positive. Instead of 9, it'll be negative 9. And now the rules I was using for addition apply, so I'm going to rewrite the polynomial and add in the vertical columns. So I'm going to have 16x to the third plus 10x squared and a negative 9. Now that's not a like term with negative 8x, so I'm going to put it further down so I remember to, when I add up the columns, remember that they're not like terms, and not to add them together. Okay, x to the thirds are like terms, so 12x to the third, 4x squared plus 10x squared, we get 14x squared. And then negative 8x stays negative 8x, and negative 9 stays negative 9. And we have now subtracted a polynomial. Moving on to multiplying polynomials. Multiplying polynomials, we must remember the exponent rule, that when we multiply two numbers that have exponents together, we add the exponents. So we have to make sure we remember to add exponents when we're multiplying. So first, multiplying we're going to have to do more than one example of because it looks different in a number of different problems. So first, if we have just one term to multiply, we can think of that as just using the distributive property, remembering to add the exponents when we multiply. So 2x squared times 3x to the third. 2 times 3 makes 6, and x squared times x to the third, add up the exponents, we'll get x to the fifth. Then we'll get 2 times 5, so we'll have 10. And remember, there's an invisible 1 on that x. So when we multiply x squared and x, we'll get x to the third. And then 2 times negative 9 is negative 18. X squared will stay x squared. And that's pretty quickly done. But what about this one? 3d minus 4 quantity squared. What that does not mean is use the power rule. This is the power rule. When we saw this, we said, oh, two exponents on the same base will multiply our exponents. That is not what's going on here. Do not just put the 3d to the second power and the 4 to the second power. The base is the parentheses. So what we have 2 of is 3d minus 4. So we have to write it twice. Written that way, then it's a lot less tempting to just put a square on 3d and 4. Most people will remember FOIL at this point. It's just a fancy memory trick for distributing, right? We have to take the first terms to multiply them together, so 3d times 3d, so 9d squared. And we have to do the outside, 3d times negative 4, so negative 12d. And then we have the inside, negative 4 times 3d, so another negative 12d. And then last, negative 4 times negative 4, so positive 16. Frequently there's middle terms to add together, so if we add those up, we'll have 9d squared minus 24d plus 16 as our answer to our multiplication. Notice it's in standard form with d squared followed by d followed by a constant. All right, so how about this type of multiplying? 2 terms times 3 terms. How do we handle that? Well, you can treat it with distributive property, like we just did with foiling. We can multiply x times all 3 terms, and then we can double back and multiply negative 3 times all 3 terms. I'll show you this way, and then I'll show you another option. Okay, remember to add those exponents. This x has an invisible 1 on it. So when we multiply, we'll get x to the third plus 2x squared minus 5x. Okay, and then we'll double back and multiply negative 3 times x squared. And I'm going to write the answer underneath its like term. So negative 3x squared, I'm going to write just underneath 2x squared. Negative 3 times 2x would be negative 6x. I'll put that under 5x. And negative 3 times negative 5 would be positive 15. And since that doesn't have a like term, I'll place it on the end. And then, same as in adding and subtracting, now my like terms are in columns for easy combining. So x to the third minus x squared minus 11x plus 15. Okay, and I said I was going to show you a second way to do it. Some people are really good at remembering lattice multiplication from elementary school days. And believe it or not, lattice multiplication can be done in algebra as well. If you have a binomial, you need a rectangle that has 2 boxes. And a trinomial, we need a rectangle that's 3 boxes long. And then we can do lattice multiplication. Remember how it works, that whatever's on the edge of the box, we multiply together and then write the answer in the box. So x times x squared we have x to the third. X times 2x, we'll have 2x squared. Then x times negative 5, so negative 5x. And then we move on to negative 3 times x squared, so negative 3x squared. Negative 3 times positive 2x, so negative 6x. And then lastly, negative 3 times negative 5, so positive 15. Notice the 6 answers we got are the same. These 6 answers are the same as these 6 answers. They're just arranged a little differently. When we're working with the lattice, if they're like terms, they're going to end up being diagonal of each other. So we can just add our like terms, write down our answer. We'd get x to the third. Negative 3x squared and positive 2x squared would be minus 1x squared, or just minus x squared. Negative 6x and negative 5x, add them up, we'd have negative 11x. And then a positive 15, so plus 15. So with these more difficult multiplication problems, you may use distributive property, or you may want to use the lattice to help organize your thoughts. For a lot of people, the arrows become really confusing when the polynomial is longer and longer, but the rectangular lattice keeps us more organized and helps us get the answer right. Okay, so let's try one more lattice just to be sure. All right, so one option, well, distributed is fine. We can multiply 2x times all 3 in the second polynomial, and then we'd have to multiply 1 times all 3 numbers in the second polynomial, and then add them up. Or we could make a lattice and add it up. So 2x and 1, 3x squared, negative 2x, and 7. So 3x squared times 2x will be 6x to the third. Remember the invisible 1. Remember this invisible 1. So 2x times negative 2x will be negative 4x squared. And 2x times 7 would be 14x. Okay, and now we have to multiply the 1 times everything, which is easy to do. So 3x squared stays 3x squared, negative 2x stays negative 2x, and 1 times 7 is 7. So we add like terms, the x squareds, the x's, and we get 6x to the third minus 1x squared plus 12x plus 7.